Welcome back to Mission Control Houston, where we are live preparing for the installation of the Cygnus cargo spacecraft for the Northrop Grumman CRS-21 cargo resupply mission to the International Space Station. Earlier this morning at 3:11 a.m. Eastern Time, 2:11 a.m. Central Time, NASA astronaut Matthew Dominic, with NASA astronaut Jeanette Epps as his backup, used the station's robotic arm to successfully capture the Cygnus cargo spacecraft. Now, the mission control team here in Houston is going to work to install it to the nadir, or Earth-facing port, of the space station's Unity module. We are providing live coverage of Cygnus's berthing to the International Space Station. Thank you.
For stable. You were right. I just needed to push it back a little farther. The valve isn't open and the door is closed.
We copy, Sunny. Thank you so much for your patience. We really appreciate it. Hopefully, we'll be getting back to you soon to let you power that on.
Okay, perfect. Thank you.
The crew is awake on board, so you are going to be hearing them call down to ground control teams here on Earth. But for our coverage today of Cygnus installation, that is going to be done here on the ground in mission control by the robo console position. This robotics officer is going to be maneuvering the Cygnus spacecraft to its installation site.
Console station on 2 for the microscope.
Console is with you. Console is with you.
Emily, just a little bit more detail on the power chain here. So that PS120 that I just mentioned, 1001, which is plugged into J4 of UOP2. The numbering scheme, by the way, of the UOPs in the lab is not intuitive. Just saying. But anyway, that's a side note. Switch 3 right now is connected to a cobalt brick to the HD encoder. Forget what I said about the tape over the LED. I just took it off. I don't know why it was there. The bigger question is that if I don't need that GFCI, I don't know how I'm going to connect the microscope to this power chain, if this is indeed where it needs to go, if I've got the right, if I'm starting at the right place with this PS120. So I'm just giving you more clarifying words on what I'm seeing here as far as the power chain goes.
We copy all CC. So at that PS120, you need to be at the J4 connection, which should lead you to the AC inverter that we're looking for.
You are looking at live views of the Cygnus spacecraft. It is currently attached.
Okay, I think I know what I did. I was looking at this is just lots of purple font here. Okay, so J4 of the PS120, and then switch 3 of the inverter.
A firm.
Okay. Thank you.
And at the switch 3, you should see the GFCI connected there, and attached to that GFCI should be a W cable, and that's what you'll plug the microscope into, is the W cable. Copy, thumbs up.
I think I need a fourth pouch of coffee now.
I was only able to relay that because I have very smart people that know what they're doing.
NASA astronaut Tracy Dyson is currently on board the International Space Station working on a separate activity. We do have our space to ground loop going out live on our coverage, so that is why you are hearing her speak with the ground team here in Mission Control Houston. However, on your screen for our coverage today is that installation of Cygnus. So it is attached to the space station's robotic arm. That was done earlier this morning by NASA astronaut Matthew Dominic, while NASA astronaut Jeanette Epps assisted him as backup. They were both in the space station cupola at the robotics workstation. They actually took control of the space station's robotic arm to grapple or grasp the spacecraft. And now it is up to Robo here on the ground in Mission Control Houston to maneuver the spacecraft to that common berthing mechanism. We have a series of different camera views that we're going to be rotating through today. These are brought to us by Cronus, who is sitting next to Robo in Mission Control Houston. Cronus manages the International Space Station's core system, computers, and networks, as well as all of our cameras. We don't have a set time for when that final installation is going to occur. We are just going to be following along with Robo today. For our coverage today, we are not going to refer to this as docking. That is because docking has a different interface. Docking allows for a vehicle to push in, and from there it uses hooks to secure its position. Those docking ports are smaller but allow for a lot of flexibility. Cygnus is, in contrast, going to berth to the International Space Station, and berthing is like installing two spacecrafts together. It's similar to how the International Space Station was originally mated together, so that opening is a lot wider, can take larger payloads through that common berthing mechanism. So our robotics officer is going to guide Cygnus into that what we call ready to latch position. Sensors are going to indicate to him that it is ready to latch, and then we will have a first stage capture followed by a second stage capture for that secure mating. There are 4 sets of 4 bolts, 16 in total. Once that bolt driving is complete, that is when our second stage is going to be complete. As a recap of NG-21's journey to the International Space Station, this Northrop Grumman Cygnus spacecraft launched on Sunday At 11:02 a.m., that's August 4th, on a SpaceX Falcon 9 rocket from the Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. The Cygnus spacecraft completed the deployment of its 2 solar arrays at 2:21 p.m. the same day. Shortly after launch on Sunday, the spacecraft performed as designed by canceling a scheduled engine burn due to a slightly low initial pressure reading that was flagged by the Cygnus onboard detection system. However, engineers at Northrop Grumman's Mission Control Center in Dulles, Virginia, evaluated the pressure reading, confirmed it was acceptable, and reworked the burn plan to arrive at the space station on the originally planned schedule. NASA astronaut Matthew Dominic successfully captured the vehicle at 3:11 a.m. Eastern Time, 2:11 a.m. Central Time. This is Northrop Grumman's 21st commercial resupply mission for NASA. NASA's commercial space program has enabled successful partnerships with American companies to resupply the International Space Station. Just like today's mission, it is a cargo mission today. There is no crew on board, but we do have over 8,400 pounds of cargo that is being delivered to the crew living and working aboard the International Space Station. Here you can see some statistics of that breakdown. Over 2,000 crew supplies, 2,790 science investigations. We also have spacewalk equipment, lots of vehicle hardware, and also computer resources on board. This vehicle is expected to stay docked to the International Space Station for about 6 months. And then when it does undock, it has a very important role as well. It's going to be loaded with trash and other obsolete hardware, and then it will be safely deorbited and burn up over the Pacific Ocean.
Station Huntsville on Space to Ground 2 for sunny and stable CO2 meter.
Huntsville, back with you for stable.
Sunny, we got the warm and fuzzy from our PD that the CO2 valve does need to be in the open position, so you're go to finish out step 3 of that procedure.
Okay, we will put it to work, and you just don't want to know what we're talking about up here.
Now I definitely know, or want to know, rather.
NASA astronauts Sunny Williams and Tracy Dyson are working on an experiment together on the space station. So that is the voices you are hearing come down on our loop. Again, though, that is a separate activity. Our installation of Cygnus is being done by our robotics officer here in Mission Control Houston. Earlier in our coverage this morning, Cygnus conducted a series of burns. The ADV3, ADV stands for Approach Delta Velocity. That ADV3 burn is our approach initiation burn. That burn allowed Cygnus to position itself directly below the station. Next, the ADV4 burn changed the speed and direction of Cygnus to have it rendezvous to a 250-meter hold position outside the keep-out sphere. Teams polled go for the vehicle to move into that keep-out sphere, and it proceeded nominally up until our capture point when NASA astronaut Matthew Dominic used the robotic arm to successfully grapple Cygnus. We are expecting to have some brief outages during our coverage today. These are normal and expected. As the space station flies around the Earth, those communication paths need to transfer between satellites. So they will hand over that data from one satellite to another as the station orbits the Earth. Right now, though, we have beautiful views of Cygnus. The space station is currently flying over Guinea in Africa. The crew is awake on board and going through their daily activities. However, we are currently in a no exercise time period. This is because we want to ensure that there are no impactful vibrations or movements of the station while the robotics officer works to install Cygnus on the International Space Station. We are headed to the nadir or Earth-facing port of the Unity module, and that is where Cygnus is going to remain installed for about the next 6 months. After we are installed today, there will be a series of leak checks conducted before opening the hatch door, and then the crew can start unloading the cargo. You'll hear us refer to this spacecraft as Cygnus, also Northrop Grumman's 21st cargo resupply mission, but it is also tradition to name a Cygnus spacecraft after a pioneer in space exploration who is deceased. This spacecraft is named in memory of NASA astronaut Richard Dick Scobie. Scobie was a United States Air Force pilot and Vietnam veteran. He was selected as an astronaut in 1978 and chosen as a
Control station on 2 for Microscope.
We're with you on 2, TC.
Family, I'm in step, let's call it 2.5. I've got the camera installed and on the C-mount back on the microscope. The cap that came off of the camera, I believe it's off the C-mount where the camera installed. It has Velcro on it, and I'm just curious, where do you normally stow this so it doesn't get lost?
We are checking. Station Huntsville on 2 for TC and Microscope.
Go ahead for Microscope.
TC, is there some Velcro on the microscope itself that you could use to sew that cap?
Yeah, absolutely. I just got a little nervous putting it wherever I wanted. So yeah, there's a round piece just maybe 5 inches below the C-mount, and it looks like a perfect place. I wanted to be sure before I left it hanging out there.
We copy your go to put it there, and we can always sew it somewhere else later if we need to, but I think that's a good place for it for now.
Okie dokie. Thank you.
You just heard teams at Marshall Space Flight Center.
Stanley, while I got you, step 2.7 says if phase slider not installed on microscope. I'm sorry, I'm not sure what that is. Wait, figure 2.
They are.
All you had to do is ask.
That's right.
They are working with NASA astronauts Tracy Dyson and Sunny Williams, who are currently on board the space station working on an experiment. We do have those live feeds going out, so that is why you are hearing that separate activity. But on your screen, you can see our live views of Cygnus. This camera view is on space station. This is in that common berthing mechanism looking out at Cygnus. Those lights you see are going to help with the orientation of the alignment of the vehicle. The robotics officer is going to be maneuvering Cygnus to the installation site, so you're going to see that slowly but surely line up together. The goal is to have that guided into what's called a ready-to-latch position. Once it's in that ready-to-latch position, sensors are going to indicate to our robotics officer that it is ready to latch. We will have 2 stages of capture. For that final installation to be complete, we are looking for 4 sets of 4 bolts, so 16 in total. Once those bolts are driven, we will then confirm when that's complete, and that's going to be our second stage berthing complete. We don't have a set installation time for that to occur. We are just following along with our robotics officer. You've already heard some chatter coming down from the space station of astronauts working on experiments, and there are many new ones being delivered on today's cargo resupply mission.
So two for Microscope.
Go on to.
2.7.2, installing the phase slider. Goes in one direction, open in another. Is that, I assume that that label is for the aperture and has nothing to do with the phase slider at all, so I need not operate this thing. True.
NTC, unfortunately, we lost you in a handover, so I got to 2.72 phase slider, and then we just picked back up a second ago.
Yeah, it's good because I always need practice with my brevity, so this is a real good indicator I wasn't. So, question is, the label aperture just above the phase slider, when it's installed, has below that a knob that rotates a ring just above the phase slider. It says closed in one direction, open in the other, and I'm just verifying that that has nothing to do with the phase slider. Number one. Number two is, what position do you want that slider? And it's not evident in that figure, too, so I'm not sure if you are familiar enough to know what I'm talking about. Do more description if you need.
I have eyes on a diagram of the microscope, and we are checking.
Heading back to some science that's arriving aboard Cygnus today is the Packed Bed Reactor Experiment Water Recovery Series. This is going to help us understand gravitational effects on filtration systems. Insights from this investigation could lead to improvements in this technology in microgravity on the Moon and Mars, and also has applications here on Earth, such as water purification and heating and cooling systems. For this experiment, packed bed reactors are structures that use packing of objects, usually pellet-like
Station Houston on 2 for exercise. Just a reminder, no exercise at this time while we press into 2 feet for Cygnus ops.
Mission copies.
A reminder from our Capcom position here in Mission Control Houston for the crew not to conduct any exercises, as Cygnus is going to be brought within 2 feet of the International Space Station.
On 2, back with UTC.
Go ahead, Emily.
So your supposition that the label doesn't have anything to do with the phase slider is correct. That is for the lens itself, and we will be adjusting that during microscope ops, so no need to do anything with that today.
Okay, perfect, thanks. I didn't know if it needed to remain in the closed or position or it didn't matter.
Good question. No action doesn't matter today.
Thank you.
A great view here, as you can see, Robotics Officer Casey Chen is guiding Cygnus over to align with the common berthing mechanism on the nadir port, Earth-facing port of the space station's Unity module. Once Cygnus is aligned with the berthing port, we're guiding it into that ready to latch position. The crew is in a no exercise period. Also important is that we have the thrusters inhibited. So these are automatic thrusters on the space station that keep it oriented in the correct position. We don't want them to go off and interrupt the mission. You might hear that call out, DSATs are inhibited. The ADCO position here, Mission Control Houston, is confirming that those are off. ADCO just confirmed that thrusters are disabled. ADCO stands for Attitude, Determination, and Control Officer. ADCO is responsible for the rotational slate of the vehicle via the International Space Station Motion Control System. They manage the global positioning systems. And we just heard from our robotics officer here in Mission Control Houston that we are about 5 minutes away from installation. We have received the final go from the flight director to install Cygnus. A nice split view on your screen of two different views. These are live views of Cygnus. On the left, you can see the vehicle with its two solar arrays deployed. And on the right, this is the camera looking out from inside that common berthing mechanism, looking at Cygnus. You can see those slow final movements as Cygnus is brought into the space station. Next up is going to be that RTL ready to start driving the latches. There will also be a series of bolts, 4 sets of 4 bolts, 16 in total. Only after that bolt driving is complete do we consider this installation complete. So we will wait to call out.
Go ahead on 2.
Yeah, I got to step 2.11, .1, and the power switch for Sable 2 is already in the on position, and I'm not seeing anything on the display. And in addition to that, I already connected the camera cables while that switch was on. Did I miss a step? I did. Yeah, concession time. So 2.8.1, when it said check, I just read it too fast. I was thinking the microscope because I was working with the microscope. And so I checked that the switch on the microscope was on, but it was actually on the unit, which makes a lot more sense. So did I honk something up?
It's like you don't even need us. You figured out the answer to your question before I could give it to you.
The part about my mistaken the procedure or honking it up. Did I honk something up?
You didn't honk it up. It's 2.8.1 is what you needed to perform.
Okay, so with the connections between the camera and the Sable already in place, am I okay to cycle the switch then, the power switch on Sable 2?
Let me double check.
Emily, by the way, the screen, it's a touch screen, so once I tapped the screen, then the display came alive. So I guess my question is, do I need to power cycle the Sable now that I already made connections, or just move on?
We copy all that Sable is on and that everything is connected. Let me double check.
Munich Matt to Earthshine.
Munich is with you on 2, Matt.
Good morning. Execution note indicates ISO of 1,000. I remember that from last time. I also thought I remember a shutter speed change. Confirm the correct settings are ISO 1,000, shutter speed 50th.
And copy all, ISO 1000 is correct. Thanks, Matt.
Copy. Confirm shutter speed 250. There's not a delta there.
And Matt, shutter speed 250 is correct. There are no other deltas there.
Here in Mission Control Houston, we received a go to push in for that RTL ready to latch position. We are going to wait to start driving those latches until after this brief upcoming handover. Again, this is a expected and planned outage, so we are going to wait for that to pass, and then we will start the berthing process. We are referring to this installation as a berthing because we are joining two spacecraft vehicles. It's a different interface than docking. This common berthing mechanism on the International Space Station, the opening is a lot wider, so it can take larger payloads. This is a similar process to how the International Space Station was mated together. After we have all of those bolts driven, we have our installation complete. Teams will conduct a series of leak checks before opening the hatch door, and then the crew will begin to unload the cargo.
Station Huntsville on Space to Ground 2 for TC and Microscope.
Go ahead, TC.
TC, when you touch the screen, did you get that message that's in 2.11.2?
No. Not that I saw, anyway.
That expected handover period has started. You can see live views now of Mission Control Houston.
Just to be clear, I haven't cycled the power switch on the Sable, so and nor did I touch the screen yet. The screen was blank, asleep, whatever you want to call that state. But and so I think I need to cycle the power switch in order to get to the initialization program.
We copy. And we are still checking. It might be just another minute.
Thanks for the heads up.
Station Houston on 2 for Butch. We have answers to some of your questions on today's timeline when you have a moment.
We just heard confirmation from our robotics officer that we have fully pushed in and we have full RTLs or ready to latch. We are go for full installation. This is the camera view from inside the common berthing mechanism looking out at the bottom of Cygnus. They are fully aligned, and now a series of latches and bolts are going to fully secure it to the International Space Station. We are currently at the first stage of that installation of the RTL, where we are ready to start driving the latches. Our installation will not be complete until that second stage berthing. That's going to be once all of the bolts have been driven. There are 4 sets of 4 bolts for a total of 16.
Right on 2 for timeline.
Hey, Butch, regarding today's activities, for your orange activity, the ULA video recording, that is to retake the video if you were unable to find that video. we checked here on the ground. We couldn't find it in downlink. The only other recommendation for that one that we have is if it's still potentially on the camera card.
Okay, yeah, we'll redo it.
Okay. For the following activity, for the PAO video recording, the intent there is to get that B-roll footage, and if there is no science, the instructions there are in the last sentence of the background for you to mock or demo some science.
Okay, we'll take some of that throughout the next couple of days. I think we'll be doing some pretty neat stuff, and we'll try to get that.
Okay, we copy. And then the last one is regarding the arm. There's a walk-off scheduled in 2 days, so that should be out of the way on Thursday.
We appreciate that. Thank you so much.
You got any other cues for us?
Sorry, say again?
You got any other questions for us?
No questions. Thank you.
First stage capture is complete on Cygnus, but we are waiting for that second stage capture to be complete before we call out that final installation time. Again, first stage capture is complete on Cygnus. We are go for second stage capture.
Station Huntsville on Space to Ground 2 for TC and Microscope.
Our first stage capture is complete. We have a go for the second stage capture. Again, that's going to be 4 sets of 4 bolts, 16 in total.
So go ahead, you.
ATC, we do need you to repeat step or perform step 2.8.1, and then you can skip to 2.11 and finish out the procedure.
Okay, so you said that I can do 2.8, so I'm essentially turning it off, and then skip 2.11?
Skip 2.9 and 2.10 and perform 2.11.
Okay, sorry, there's a fan going off right here. That's probably why I didn't understand that, but that makes total sense. Thank you.
Thank you so much for your patience.
The driving of those bolts is in progress.
Okay, Hansel, finally I am done with the microscope setup, and FYI, I did receive the message in 2.11.2, selected OK. However, 2.11.3 is a no perform because it was already brought up in an operating state that was on, so I didn't perform .4 or .5.
And we copy all. Thanks, TC. We appreciate it.
Yeah, you bet. And just a quick question about the orientation of the microscope. And I heard you say Matt's coming. Matt has an activity with this, and so maybe he'll adjust it however he wants. But I tried to make it as similar to the Figure 1 as possible, so it's it's not in the translation path, but it's oriented perpendicular to the rack face.
Copy, yeah. And Matt's activity later is to reposition it out of the way so that it is stowed and you guys are free to translate without worrying about hitting it because we don't have ops with it until Thursday.
Ah, okay. Well, that answers my second question. I'm going to go ahead and put this box, and I think this is commensurate with the stow note. I'll put the foam box back in the PMM because we won't need that for a while, correct?
Affirm, TC.
Okay, just a note about this foam box. It looks like it's been around for a while, but I really think it's the model for foam boxes for two reasons. One is it's got these nice compartments inside with Velcro, which has worn off. The glue probably needs to be real special to stick to this foam, but the effort to make these netted covered pockets to stow things really makes it a joy to open up and operate with. And also these straps, these nylon straps that hold the box together are also secured by Velcro so that they don't just float freely. And I just wanted to share my thoughts on this foam box, that I think it's well designed and very helpful here in orbit.
That's awesome feedback, and we'll make sure to pass that on to the PD.
Please do, and share with other PDs as well that it's a box to model after for whatever is a relevant project.
Absolutely. We try to share those kinds of things amongst the community whenever we can. Make things easier for you guys.
Great. Houston station on 2 for barcode of the probe.
We are with you on 2.
Okay, the barcode is 00274789 Juliet.
Jeanette, we copy 00264789 Juliet. That's a good number.
This is 0027, sorry, 00274789 Juliet. Thanks.
Copy.
For the installation of our Cygnus spacecraft today, we have confirmation of the first stage of that berthing process. We are now waiting on those bolts to drive. Only when those finish driving is our installation considered complete. (5:33 a.m. Eastern Time, 4:33 a.m. Central Time. The 50th visiting vehicle to the International Space Station captured by the Canadarm2. The Cygnus spacecraft, named SS Dick Scobie, supporting Northrop Grumman's 21st commercial resupply service mission, was first grappled at the hands of NASA astronaut Matthew Dominic, with NASA astronaut Jeanette Epps acting as his backup. That first grapple time happened at 3:11 a.m. Eastern Time, 2:11 a.m. Central Time. Next, controllers here in Mission Control worked to successfully install the spacecraft on the International Space Station, and that just occurred at 5:33 a.m. Eastern Time, 4:33 a.m. Central Time. This concludes our coverage today. Thank you for joining us. This is Mission Control Houston.